Hello everyone. In this lesson, I am going to tell you about different types of organic reactions. In previous lessons, we have explained how the reaction takes place, how the reactant will be attacked by the attacking reagent, how many types of bond cleavage takes place, and how many types of attacking reagents are there. Now we come across different types of organic reactions. There are many organic reactions are there, including oxidation and reduction, but they are purely not organic in nature. That is common for organic and inorganic. That's why we are going to consider purely organic reactions such as substitution reaction, replacement reaction, addition reaction, condensation reaction, or elimination reaction, rearrangement reaction. Even though there are millions of organic compounds, all these organic compounds generally they undergo these five different types of reactions. We'll see one by one. Reaction in organic chemistry: substitution reaction, addition reaction, condensation reaction, elimination reaction, rearrangement reaction. These are the different types of reaction we come across in organic chemistry. First one is substitution, or it's also called as replacement. As the name indicates, it's a replacement of one group by the other. That type of reactions we are going to call it as a substitution or replacement reaction. Generally this takes place in case of saturated hydrocarbon. Already explained about the saturated and unsaturated hydrocarbon in the previous videos, in previous lessons. Saturated hydrocarbon is the one in which carbon-carbon bond is satisfied by a single bond. Those are called as alkanes, or they are called as saturated hydrocarbons. Generally they undergo this type of substitution or replacement reaction, which going to have sp3 hybridized carbon in them. They generally going to have a single bond, and they undergo this type of replacement or substitution reaction. But this also takes place in case of aromatic compounds like benzene and its homologous, which also contains sp2 hybridized carbon. So alloalkanes, when you consider, those are saturated hydrocarbons having a halogen in them. So they generally undergo substitution reaction by KCN, where it has been replaced by CN. Br is replaced by CN. Such type of reactions we are going to call it as a substitution reaction. Or the famous reaction of chlorination of methane, halogenation of methane. That's also an example for substitution reaction. In case of methane, when made to react with the chlorine in presence of a diffuse sunlight, one of the hydrogen of the methane is replaced by the chlorine to form the methyl chloride. This is another example. Similarly, aromatic compounds, even though they are going to contain the unsaturated double and alternative single and a double bond, they are not going to behave like a unsaturated compound, but they are going to behave like a saturated compound. That is, they are going to have a special character, resonance character, or we are going to call them as aromatic compounds. Aromatic compounds also generally they undergo substitution reaction. So when you consider the substitution reaction, there are three different types of substitution reaction can take place. If it is substituted by an electrophile, it can be substituted by a nucleophile, or it may be substituted by the free radical. Based on that, they are classified into free radical substitution reaction, electrophilic substitution reaction, nucleophilic substitution reaction. First one we'll see free radical substitution reaction. I already told you that free radicals are the reactive intermediate that have been obtained by the homolytic cleavage of covalent bonds are organic compounds. So when you consider the free radicals will going to be used as one of the adding. When you consider the mechanism, you come across the chlorine free radical, that going to give that type of reactions we are going to call it as free radical substitution reaction. Substitution reaction is initiated or it is started by a free radical. Such type of reactions we are going to call it as free radical substitution reaction. Chlorination of methane. This reaction involves the attack of the free radical CH4 plus Cl2. When they are going to combine together, you are going to get a methyl chloride. This reaction, in the beginning, when you consider the mechanism, the chlorine in presence of the light, it get converted into chlorine free radical. That chlorine free radical will going to attack the methane to form the methyl chloride. Such type of reactions are the example for free radical substitution reaction. Similarly, electrophilic substitution reaction, when you consider the benzene, sulfonation of benzene, nitration of benzene, Friedel-Crafts reaction, all these are example for electrophilic substitution reaction on benzene. So here we are going to consider the nitration of benzene, in which nitric acid and sulfuric acid, they are going to combine together to form NO2 plus. That NO2 plus will going to attack the benzene to form the nitrobenzene. This type of reaction is an example for electrophilic substitution reaction. Similarly, you are going to have a nucleophilic substitution reaction in which the attack is taken by the nucleophile. Attack of the KCN on alkyl halides. Here in the first step, KCN will get converted into K plus Cn minus. That Cn minus will go and attack the carbon. Thereby the Cn minus is a nucleophile. The attack of the nucleophile, the reaction is initiated by the rate determining step is the attack of the nucleophile that leads to the substitution reaction. This we are going to call it as the nucleophilic substitution reaction. This is one type of reaction. Second type of reaction we come across in organic chemistry is addition reaction. This reaction involves, as the name indicates, we are going to add to the unsaturated hydrocarbon which is going to contain a double bond or a triple bond. Those compounds, they undergo this type of reaction and they get themselves converted into a saturated or a single bonded molecule. Such reactions we are going to call it as such type of reactions we are going to call it as the addition reaction. Here usually when you consider a unsaturation, when you consider a double bond, you are going to have one sigma bond and one pi bond. So pi bond one pi bond is get converted into two sigma bond. This type of reaction takes place. Here generally the addition takes place across the double bond, across the multiple bonds. It may be a single bond or it may be a double bond. Generally sp2 hybridized carbon get converted into sp3 hybridized carbon. This reaction takes place for alkenes, alkynes and carbonyl compounds and dienes. Addition of alkenes, when you consider the HBr to alkene, across here I have taken the unsaturated symmetrical alkenes that when made to react with HBr, you are going to get the H gets split as H plus and Br minus, and H will go and attack one carbon atom, Br will go and attack the other carbon atom. Again, these are also classified depending upon the type of the initiator, type of the propagator which going to propagate the reaction as free radical, electrophilic and nucleic addition reaction. Free radical addition reaction, when you consider the unsymmetrical alkene in presence of the peroxide, it going to add and you are going to get the saturated compound. This is an example for Karash rule or anti-Markovnikov's rule. The negative part of the adding substituent will go and attack the carbon atom which is going to have least number of hydrogen atom. This is an example for free radical mechanism. I already told you the free radicals are generated and the free radical reaction takes place in the vapor stage and also in presence of peroxide and in presence of H nu or photochemical reaction. Here in presence of peroxide, your peroxide will going to react with HBr to form H free radical and Br free radical. That Br free radical will go and attack the carbon. Br free radical will be the attacking reagent. Therefore, here we are going to call it as the free radical addition reaction. Similarly, unsymmetrical alkene to hexene when you add in the absence of peroxide. When you do the reaction in presence of peroxide, you are going to get the anti-Markovnikov's product or which going to obey the anti-Markovnikov's rule, or that is also called as the Karash rule. But in the absence of peroxide, the reaction takes place as the free radical, as the electrophilic or the heterolytic cleavage takes place. This is an example for addition reaction. Similarly, nucleophilic addition reaction, when you consider the acetaldehyde when undergoes the reaction with the amines, you are going to get an aldamine. This is an example for nucleophilic addition reaction. Here also the reaction takes place in acidic medium. So, your NH2R get converted into R plus and NH2 minus. NH2 minus will go and attack the carbonyl carbon of the acetaldehyde to form the aldamine. Third type of reaction that we come across in organic chemistry is a condensation reaction. In this reaction, as the name indicates, they are going to condense, they are going to reduce. In this reaction, the two molecules of the same or different organic reactant combine together to form a new product without the elimination of the simple molecules. Nylon, the cloth that we are using, it's an example for condensation reaction. Here we are going to take the adipic acid and hexamethylene diamine. It's a polymerization reaction, thereby N moles of hexamethylene diamine when made to react with N moles of adipic acid, condensation reaction takes place with the removal of water, and you are going to get a nylon 6 polymer. Condensation, Perkin condensation is also there. Here also benzaldehyde. Whereas in the previous case we have taken two different acids, here also we are going to take two different reactant. One is a benzaldehyde, other one is an acetaldehyde. When they combine together, they undergo with the condensation, with the removal of CH3COOH, you are going to get this adipic acid. Similarly, I can take the two same reactant only instead of taking two different reactant. Here I am going to take the same reactant. They also can undergo the reaction in presence of KCl. Certain conditions are there. They may condense themselves to form the benzoin. So benzoin condensation is also an example for condensation reaction where the two molecules of benzaldehyde will take part in a chemical reaction. The next type of reaction that we come across in organic chemistry is the elimination reaction. As the name indicates, we are going to eliminate, we are going to remove. So this is exactly reverse of addition reaction. In case of addition reaction, we are going to convert the unsaturated sp2 or sp hybridized carbon compounds into sp3 hybridized into saturated, from unsaturated to saturated by adding. Here we are going to convert the unsaturated containing a double or a triple bond. We are going to get the double or a triple bonded molecule from the saturated molecule by eliminating something. Such reactions we are going to call it as an elimination reaction. Reaction which involves the elimination of atom or group of atom from saturated compounds to form a double or a triple bonded molecules is called as elimination reaction. It takes place in saturated compound which involves the conversion of sp3 hybridized carbon into sp2 hybridized carbon. These reactions are reverse of addition reaction. Example, when you consider dehydrohalogenation of alkyl halides. Alkyl halides, when the undergoes a reaction, when made to react with the alcoholic KOH, you are going to get convert a saturated compound into unsaturated compound with the elimination of water and KBr. This type of reactions we are going to call it as elimination reaction. These elimination reactions are also classified into two types, beta elimination and alpha elimination, depending upon where the elimination is taking place. If the elimination taking place from the same carbon atom, which is going to contain the two groups which have been removed from the same carbon atom, that type of elimination we are going to call it as alpha elimination. If two or more groups are lost from the same carbon atom, then it is called as alpha elimination or 1,1 elimination. Dichlorocarbene, which is an intermediate, is formed using elimination. Similarly, the very popularly form of elimination we come across, very rarely we come across alpha elimination, but we come across a large number of beta elimination reactions. Here, if the two atoms or the groups are lost from the adjacent carbon atom, that type of elimination we are going to call it as a beta elimination or 1,2 elimination. So when you consider the alcoholic KOH, dehydrohalogenation of the N-propyl bromide to form the propene, this type of reaction. Here the elimination is taking place between the two adjacent carbon atom. One hydrogen is eliminated from one carbon and bromine is eliminated from the other carbon. Both the carbon atoms are adjacent to each other. This type of reactions we are going to as beta elimination. And the last type of reaction that we come across in organic chemistry, that is called as rearrangement. As the name indicates, reshuffling. They are going to make an arrangement themselves only. They are going to rearrange themselves only according to their convenience, according to the stability. Such type of reactions we are going to call it as rearrangement reaction. The reaction proceeds by the rearrangement or reshuffling of the atoms of the group in a molecule to produce the structural isomers of the original molecule are called as rearrangement reaction. Again, there are two different types of rearrangement reaction. One is called as intramolecular, other one is called as intermolecular. As it indicates, intramolecular means between the interclass computation ಅಂತ like that they're going to tell. Intra means the rearrangement taking place from the same molecule. Such type of rearrangement we are going to call it as intramolecular rearrangement, in which the migration of the group gets completely detached and it is later on reattached is called as intramolecular rearrangement. So they have given some examples. One butene is getting converted into butene. The next one is called as intermolecular rearrangement. The rearrangement in which the migration of the group is never fully detached from the system during the process of migration is called as intermolecular rearrangement. One is called as intra, within the molecule it gets detached and again it is attached. In another case, what happens? It is not detached at all. It will be there inside that. Such type of rearrangement we are going to call it as the intermolecular rearrangement. So when you consider, there are 4 different types of reaction: substitution reaction, free radical, electrophilic, nucleophilic substitution reaction, addition reaction, free radical, electrophilic, nucleophilic reaction, elimination, beta elimination, alpha elimination, rearrangement, intermolecular and intramolecular. So like this, in organic chemistry you come across these 5 different types of reaction along with oxidation and reduction. Thank you. All the best.